Okay, so here we go. Our statistics and probability Playposit. This will be one of two Playposits that you do for statistics and probability. So these are self-paced lessons. They're not going to be super hard, but you should pay attention and write a few things down. I'll tell you what to write down so that you can answer the questions in Playposit as they come up. Okay. So you probably already know a little bit about statistics, right, and probability. Probability is the likelihood that something will occur, right? If you've ever played a board game and you've used a spinner, if you used a dice, or you've played cards, those are easy to calculate probabilities, right? If there are 6 numbers on the spinner, you have a 1 out of 6 chance of hitting any number, right? Provided that it doesn't have any issues with the spinner. But then there's some things that are a little bit more difficult probability, like the weather. Weather meteorologists use this probability to tell us whether or not they think it's going to rain. So you get like a 50% chance of rain, 60% chance of rain, something like that. They're getting pretty good at it based on weather patterns and weather conditions and stuff like that. But that really is probability, right? And they don't know for sure. They're just doing it based on data that they've gathered. And we'll talk a little bit about that as we move forward. Right? So probability is the calculated likelihood that something will happen, right? And you can either calculate it from past observations, which is called empirical probability. So we look at the weather patterns and we notice when these things happen, it's probably going to rain, or when these weather patterns and these types of air currents, et cetera, happen, it's probably going to snow, this temperature, that temperature, whatever. That's empirical probability, calculated from past observations. Or it's calculated from known elements, like when you flip a coin or when you roll a dice. That's theoretical probability, and that's mostly what we're going to talk about in this class because it's the easiest to observe, the easiest to measure. Or it's based on assumptions, subjective probability, right? So it's something that we don't know for sure, but we make an assumption. And this comes into talk about things like vaccines, right? We believe when the vaccines first started, we believed, okay, you take this vaccine, you're going to be more protected from COVID, right? That was subjective because nobody had taken the vaccine yet, right? So that became a subjective probability at the beginning, and now it's moved to more of an empirical probability because we have some data, right? We have data that if you take this vaccine, you are going to be more protected from COVID, right? So things adjust as they go along, right? And at some point, it may even become theoretical probability because we may have enough data that's more or less known element, right? And we're not quite there yet. I think we're more right now on the empirical probability thing when it comes to vaccines. So let's talk about theoretical probability and something that you probably, and I'm using that word specifically, you probably know the answer to this one. If I flip a coin, and provided it's a fair coin, it has one side heads, one side tails, just like a normal coin, what is the probability that it's going to land heads up? Right? You probably know the answer to that, right? 1 out of 2, 50%, half the time, right? That's its theoretical probability. What about if you're rolling a dice? If you roll one dice, or one die as it's called, and it lands on, what's the probability that it's going to land on the number 5, right? Or pick any number, right? There are 6 sides on that dice. If you roll it, it's going to land on one of those sides, right? So if it lands on the 5, that's 1 out of 6. So there's a little bit of vocabulary here that I want to make sure that you have. So we're going to like you to pause the video and write these things down after I go through them. Just make sure that you have them because these questions are coming up in the Playposit in a few minutes, right? So I'm going to ask you to ask you questions about this vocabulary, right? So an experiment is an activity with an observable result. If you flip a coin, that's an experiment. Right? A sample space is the set of all possible outcomes, right? So if we're talking about the coin, it could be heads, it could be tails, right? You don't flip a coin and it lands on its side, right? Unless you're some sort of magician, right? And there's 2 possible outcomes. It lands on its head, lands on its head, lands on its tails, never lands on the edge. So that's all the possible outcomes, only 2 possible outcomes there. The event is a subset of the sample space, right? So if it lands on heads, that's the event, right? It lands heads up. And the outcome is the result of an experiment. So if you flip the coin, it lands heads up, that's the outcome, right? Or the sample. And a little bit more of a graphical description here, right? The experiment is you flipping the coin, The sample space is it's either heads or tails, and sometimes we use this what's called this probability tree that you can see here in the slide, where we have the experiment branched out into two possibilities or two probabilities, right? The one probability is heads, one probability is tails, and then the heads is highlighted because that's the what we want. That's the sample space. That's what our desired outcome is for the experiment. And then the event, we just write the letter H because that's the single event. That's just the designation of the event. And then the outcome, you can see that the coin is flipped. It's a lot of different ways to say similar things, right? But I want you to kind of get a sense of the vocabulary. And once again, you should write down this vocabulary. If you haven't done so yet, pause the video, write down this vocabulary so that you have it for the Playposit questions that are coming up. I want you to get a good score on the Playposit. So write those down. You don't have to write them in your notebook. I'm not going to check, but you should write them down someplace. All right. So probability we talked about is a way of communicating a belief that an event will occur, and it's expressed as a number, right? Because we're engineers, we need numbers for things. We express it as a number between 0 and 1, right? So that means it's a fraction, and I know you all love fractions. It's a percent, it's a decimal, right? Those are the same things, right? Percentage can be set up as a fraction over 100, right? Decimals are fractions, tenths or hundredths or something like that. And this one you may not be so familiar with, but it's called odds, right? And odds are what you hear if you are gambling on something, right? The odds of that happening are 1 out of 2, right? The odds of me flipping a head on a fair coin are 1 out of 2, right? Or the odds of rolling a 5 are 1 out of 6, right? So you'll hear it expressed that way. And that's really just a way of saying the same thing. I'm not sure why people tend to use odds, the word odds more often, but maybe it's just so it sounds like less math, but there's no less math, it's the same thing, right? So the total probability of all possible events has to total 1, right? So I can either flip heads, which is half the probability, which is 50%, or I can flip tails, which happens 50%. So those two things have to add together to be a total of 1, right? And that's the key when you're talking about probability, and people make millions of dollars gambling, or casinos rather make millions of dollars working on these probabilities so that they all equal 1. They know what every probability or possibility is for the outcome of a game, right? Flipping coins, dealing cards, rolling dice, whatever. They know all those probabilities. Okay, so I'm going to pause the Playposit here. You're going to get a vocabulary check. Make sure you have those things written down. If not, now's your chance to go back and get them. Okay, so you've answered the first set of questions. Now we're going to do an experiment. So either find a coin or use an online coin flipper. If you just Google coin flip, you'll get this cool little graphic that you can click and it'll flip the coin for you, right? And presumably it's set up to be a fair coin flip, so half the time. So flip the coin. Did it come up heads or did it come up tails, right? It's going to be one or the other. And half the time it's going to be one, half the time it's going to be the other. But if you said you had 50% of a chance for it to come up heads, right? When you flip that coin, did it come up heads or did it come up tails, right? So it could come up one, it could come up the other. Sometimes probability isn't the same as reality, right? Because probability is a calculated number, right? And we're going to talk about sort of the difference here. So I want you to do that same thing. Flip that coin 6 times, but before you start, write down how many times it should land on heads. Right? That's something you should be able to figure out. How many times, if you flip this coin 6 times, how many times should it land on heads? And then I want you to actually go and flip the coin 6 times and see if your prediction was right. So we're going to pause here and have you do that. Okay, so you should be done with that. Now I want you to flip it 4 more times, right? And in these 4 times, how many times should it come up heads? Think about that, write it down. After you're done, was your prediction correct? Add those 2 things together. So you have a total of 10 coin flips now. You should have a number in your head about how many times that coin should have come up heads. And then you have an experimental result for how many times it actually came up heads, right? Those 2 things might be the same and they might not be the same, right? But what you should be seeing is that your results are getting closer to the theoretical probability. So I'm going to pause the video here. It's going to pause on its own, actually. And you're going to enter the results of your experiments, right? If you've not done those experiments, then do them. Flip the coin a total of 10 times. Write down how many times you think it should come up heads, and then how many times it actually comes up heads. Okay, we're back from that pause. Some of you may have gotten 50%, right? You may have gotten 5 out of 10 times it came up heads. Some of you may have gotten something a little bit different. It's okay if you, whichever one you got, right? What you should be noticing, though, is that as you flip the coin more and more times, the result gets closer to that theoretical probability, right? If you flip the coin 10 times, you might have got 60%, you might have got 50%, you might have got 40%. Some of you might have gotten extremely lucky and got like 1% or 100%. I don't know. But as you flip that coin more times, if you flip it 100 times, 500 times, 1,000 times, that number that you get is going to get closer and closer and closer to the actual theoretical probability, which should be 50%, right? And this is the difference between experimental and theoretical probability, and it's something that we tend to call the law of large numbers, right? So the more times you run an experiment, the closer your result gets to the theoretical probability, right? So that's really important right now because we are talking about COVID vaccines again. All right, so I want you to think about the law of large numbers as it relates to COVID vaccines, right? When the first people got their first vaccinations, we had a theoretical probability idea that they would be protected a certain percentage from the worst effects of COVID, right? And I don't remember exactly what that number was, but they thought, okay, well, if you take the vaccines, then you're going to be protected. Let's just say it's like 75% from the bad effects of COVID, right? Which is great, right? They had a theoretical probability. They didn't know because they had not done experimentation, right? They had not given this vaccine to people, so we didn't really know. But they had an idea. They had a theoretical probability. The more trials we conduct, the more people that take that vaccine, the more our reality gets closer to the theoretical probability, right? We're seeing that it does, in fact, protect you a very high percentage, right? But as we go through that, we might need to adjust our theoretical probability, right? This is not coin flipping that we're talking about, right? There's a lot of factors here. So sometimes we adjust in the engineering or scientific world, we adjust our theoretical probability based on that experimentation, right? So as more people take the vaccine, we say, okay, well, they're being protected, 75%, 80%, something like that. So we may adjust our theoretical numbers to conform to what the experiments are actually showing. And then we get to a point that says, oh, wait a minute, we all need to take boosters because what we're noticing is that it's only effective for a certain amount of time, right? So then we all go take our booster shots. And we notice that brings us closer back to the theoretical probability, right? So theoretical probability can shift and can adjust based on experimental probability, right? So those two things kind of work together. So I want you to think of the law of large numbers, not just about coin flips, but about reality, right? So as future engineers, this is something that you're going to do, right? You're going to experiment, you're going to learn things, and your probability for things to happen is going to adjust. All right, so a quick review. Probability is the likelihood that, the calculated likelihood that a given event will occur. The law of large numbers tells us that the more times you do something, the closer the results become to theoretical probability. And then you have your vocabulary words there. I'm not going to read to you. You guys know how to read. That's a quick review, and that should be the end of Playposit number 1.